Our home plate for tonight, pages 216 and 217 only. There is tutoring tonight, or today. It's free, of course. It's gold. And we're good like this. Bear with me today. We're gonna crank it up a notch. Now, check this out. So the first four modules of the program, including everything that we covered for Algebra 1, laid out the foundation and laid out the basic tasks and concepts of everything we're going to see throughout the year. And you saw that the day before yesterday when I did the whole functions, the type of functions we covered, what they look like, the graph, and the transformation, right? You guys remember that? So hopefully that kind of like covered all the little spaces that you had that maybe you had questions on. But from this point forward, all it is basically the same structure of whatever it is, the tasks, steps, and such, but they just add a couple more things to do. And you'll notice that with one of the examples that you see today, but without going into it. So our objective for today, I can solve systems of equations. Now, we have been working on systems of linear and quadratic equations, but for today, we're going to take a little side step. We're going to stay with systems of linear equations, systems of linear equations. You're like, Mr. Q, didn't we just cover this at the beginning of the school year? Yes. But we're going to, like I said, we're going to add a couple more steps to it, okay? So, where have we been? We've been solving them by what? By graphing, substitution, and elimination. And most of the time, we've been using substitution and elimination to get used to the algebraic portion of it. But also, on a different note, I said, look up, please, and this is where some of you get confused. Some of you don't know whether you're looking at a system or just an equation. Once you substitute or eliminate, you end up with a quadratic. What is that, Mr. Q? A quadratic equation. In order to see it clearly, make sure you leave it equal to 0, x squared, and then whatever's left. So like that, you guys can choose the method of solving. These are the different methods. Now, here goes the lifesaver, or the last option for those of you that totally get lost with the processes. Here it goes. Some of you get lost with completing the square. Some of you get lost with square roots because it's twice and you're like, why did we do it again? And so on and so forth. Some of you get lost with the factoring by grouping. And we've been practicing all that, okay? Some of you get lost with graphing. Well, guess what? The last option, or the last remedy, or the lifesaver of everything is the quadratic formula. Why, Mr. Q? Because as long as you know the quadratic formula, you write it down, your equation is in standard form, so you just identify A, B, C, I substitute, then simplify. At the end, you come up with a number. That's the solution. You don't have to remember process or anything. Just remember the formula, substitute values, and simplify. Does that make sense? Yeah, because all the other ones require a lot of processes if you really think about it, right? Require a couple things you need to remember to do, and so on and so forth. So from there, we don't need a Ferrari model because we know what the definition are for the system of equations, what they look like, and what they don't look like. We came up with hashtags. From there, we did something like this, yes? Then something like that, and then we got to this one yesterday, and I said, I'm going to elaborate on this later, which is today. You don't have to copy this, but check this out. Let me show you an application of what we covered with systems of quadratic and linear. It says, a tour boat travels around an island in a pattern that can be modeled by the equation 36x squared plus 25y squared equals 900, and a fish boat approaches the island in a path that can be modeled by the equation 3x minus 2y equals negative 8. First of all, what is your instinct to do with those two equations? Make it a system. That is correct. That's the first thing we should do. Don't copy this. I'm just going to show you the setup. This would be 36x squared plus 25y squared equals to 900. The second one is 3x minus 2y equals negative 8. Now, what we covered the other day should let you know what kind of functions you have in front of you by now. Look at them. Tell your neighbor, what kind of functions do we have in front of us, please? Very good. Check this out. By now, your noodle should see, well, there's a exponent on the x, There's an exponent on the y, therefore this is a circle when both variables have exponents. And we wrote that on the little table that we did, yes? Now look at this one. None of the variables have an exponent, so this is a linear. All right, now let's find out why they chose that for this setting. Look up, please. It says, a tour boat travels around the circles do get around. So there's a tour boat going in circles around the island. And then it says, a fishing boat approaches. Now, a fishing boat usually doesn't go around its home. Fishermen get on the boat around 2, 3 in the morning. They leave, go into the seas for about 5 to 6, sometimes 8 hours, sometimes days. But let's say they went for 6 hours. They went to see what they fished. They get all the fish, bring it back, and they sell it in their market. When they're coming back, all they do is they come back home. So they're coming back home to the island. What does that look like? A straight line. That's why this is a linear. So what they want to know is, all right, guys, here's a tour boat. It's going in circles with tours. Will it collide with the fishing boat that will come to shore? What do we call that when they both intersect? A solution. And in this case, a collision. Now, how do we solve that? What options do we have? Graphing, substitution, elimination. Now, by now, hopefully you already figured out it's a lot of work whether we do substitution or elimination. Is that correct? You notice that on the home plate, and it's a lot of complication. We're not going to do this one because I know that we can actually substitute, get everything done. A lot of computation, come up with a number. We're not going to do it, but I'm just showing you the steps. Does that make sense, though? Yeah? All right. Where I do want us to go is this next part, 3-dimension. All right? So we started with systems, and just pay attention to this part. Here we go. Here's the system. And whenever we graph a system, we graph it on the coordinate plane. Here's X, here's Y, and the intersecting point of 2 lines is the solution. But this is only in 2 dimensions. All right? Now, I'm going to try and refresh your memory from middle school. Some of you that were with me, I said, all right, guys, I'm going to introduce you to the 3rd dimension. Ready? Here we go. So I said, some of you, when you get to geometry, your teachers are going to show you about the plane. We covered some of that definitions, but I said, check this out. So I'm going to grab a point. There's a point here in the air. Ready? Here it goes. Ready? Here it goes. Okay, I have it. I'm going to stretch it. Okay, here it goes. I'm going to stretch it, and it became a plane. You're like, what just happened? So here we go. So now I have a plane. Not an airplane, a plane. This is what we call a plane in geometry. But a plane doesn't stop here. It keeps going. Check this out. So I'm going to stretch this side to side and top to bottom as much as I can. Ready? So I'm going to go. There it goes. You're like, can you guys picture it now? It's an invisible force right here. It's like an invisible, if you want to call it a wall. That's a plane. It keeps going forever. Okay? But for the purpose of right now, so that you can understand the 3rd dimension, here it goes. Here's the plane. I'm going to bring it back. Here it is. Do you guys see the X and the Y axes in there? Okay, good. Some of you don't, so let me show you. There it is. Here's the paper. Ready? You guys see the X and the Y axis? Okay. Do you see the point of origin? Okay. Well, what if I told you that aside from being the point of origin, there's another axis going through there? They're like, what? Okay, let me put it like this. All right, give me a second. Do you see a point right now? Okay, a bigger point, yes? But as soon as I tilt this sideways, you see the x-axis, the y-axis, and this sticking out is the z-axis. Because now I tilted the plane sideways. When we have the coordinate plane like this, this is facing us, and it's like from the bird's eye view. Let me show you what it looks like in a tilted view. Here's the x. The y, check this out. I'm going to push it back. Now it's laying down. Do you guys see it? Here's the x. Here's the y. It's laying down. Do you guys see it? Now I'm able to see the z-axis. Do you guys see what I'm talking about? So once again, now we're going to be talking about the third dimension, and the reason I brought that up because I want you to copy this. Woo! Let's go! Exactly. See how you guys are like, bam, let's go. No, but that's what it is, and you're going to see how we're going to graph these solutions in third dimension. Okay? Copy that, please. To solve the system by substitution, they give us a set of negative 2x plus y plus 3z equals 20, negative 3x plus 2y plus z equals 21, 3x minus 2y plus 3z equals negative 9. Copy that, please. All right, here we go. All right. Here we go. Writing pencils down. Look up to the screen. Close those iPads. I don't want you distracted, please, because, like I said, it's same processes, but I'm saying it requires just extra tasks to do. So here we go. I'm pretty sure you're going to follow along very well, but I need you guys to stay focused. Writing these pencils down. When I ask you to copy, you copy, and so on and so forth. There it goes. Here we have a system of equations. When I asked you for solving a system of equations, what was step one? Step one was to solve one of the equations for one variable. It didn't matter which variable, and it didn't matter which equation. The only thing I asked you, which one would be the easiest to solve for? So look at it. Do you see an equation with one variable already by itself? The first and the second. So at this point, I can choose either the first equation or the second equation to solve for that variable needed by itself. Me, the way my noodle works, I usually go with the very first one I see, so I'm going to go with the top one. So writing the pencils down, pay attention. Here we go. I'm going to take the first equation, and you're just paying attention. Negative 2x plus y plus 3z equals 20. And I'm going to leave y by itself. To leave y by itself, I need to get rid of this and this. So what I do, plus 2x minus 3z, plus 2x minus 3z. We're left with y equals 2x minus 3z plus 20. Copy that. All right, a side note for those of us that write with our feet, look up. Whenever you're sketching or writing your Z, some of you, those look like 2's. So that you can distinguish your 2's from your Z's, put a little dash through the Z. So like that, you know those are going to be your Z's. Why? Because once we get into all the computation that you're going to do, some of you are going to get them mistaken with 2's. So please, pretty please, do me a favor. All right, writing your pencils down, look up to the screen. Any questions on step one? No. So I use the first one, and I solve for y. So think about it. Now that it's solved for y, what am I going to do with this value to the other two equations? substitute. That's why it's called substitution. So watch. Writing utensils down. Let me just write it out so you guys can see it. The second equation, I'm going to write it here. Negative 3x plus 2y plus z equals 21. That's this one. Now I'm going to write this one on right next to it. 3x minus 2y plus 3z equals negative 9. But now, instead of y here, what do I write? 2x minus 3z plus 20. And here, instead of y, what do I write again? 2x minus 3z plus 20. All right, so now check this out. So I don't lose where I'm at. Whenever there's a coefficient, remember to put this in parentheses, bring down the coefficient. Are you with me? Now I bring the rest down. Negative 3x plus z equals 21. What is the coefficient here? Negative 2. Bring down the 3x plus 3z equals negative 9. Copy that, and then we'll continue together after that. As you're finishing copying that, recap. Step 1, choose one of the equations and solve for one variable. I chose the first one. I solved for the variable y. I isolated y. There it is. Step 2, substitute that equation into the other two equations. Did I do that? Yes, there they are. What do you think step 3 is going to be? Simplify each one. But yeah, we're going to combine within that step. So I'm going to switch to red. The first thing I'm going to do here, so I don't forget, look up, I'm going to distribute the coefficient here. 2 times this, and times this. So that gives me 4x, and it's positive, minus 6z plus 40. From there, I bring everything else down. The negative 3x, the positive z equals 21. Am I done? No, let's combine like terms. What is negative 3x plus 4x? X. What is negative 6z plus 1z? Negative 5z. But now look up. I have constants on both sides of the equation. What do I need to do to the 40? Subtract 40 to each side, and that leaves me with equal to negative 19. Look at it. Can I combine anything else on that one? No. I'm going to switch to green now, and I'm going to simplify the other equation. Start distributing first. But notice the coefficient now it has a what? A negative. So now it's negative 2 times this, negative 2 times that, and negative 2 times that. So this is negative 4x plus 6z and negative 40, because there was a plus 20 there. Bring down the 3x, bring down the 3z, equal to negative 9. Am I done? No. Combine like terms. What is 3x minus 4x? Negative x. What is 6z plus 3z? 9z. Now I have constants on both sides, so that I need to get rid of this 40. So what do? Plus 40 plus 40. That leaves us with equal to 31, because this cancels. So it did this one. Okay. Questions up to right there. So step 1, isolate one equation, one variable. Step 2, substitute into both equations. Step 3, simplify. Now, what we just did, guys, we combined all 3 big equations and made them into 2 little ones. Look at it. We have x and z, x and z. Now look what I'm going to do. I'm going to write this one. And then the other one, I'm going to write it right underneath. Who sees it now? What method can we use from this point forward? Elimination. So watch. What is x minus x? 0. Negative 5z plus 9z, that's 4z. Negative 19 plus 31, that's 12. Divide by 4 both sides. It's a giant 1, so we're left with z equals 3. Am I done solving this little system? No, now I need to substitute that and get which other value? X. Which one do you want me to use, though? The red or the green? All right, let's use the red. So I'm going to use the top one. So I'm going to write x minus 5, parentheses, equal to negative 19. Instead of z, I'm going to substitute 3. Therefore, x minus 15 equals to negative 19 plus 15 plus 15. X equals negative 4. How are we doing up to right there? How many variables have we solved for already? 2. Which one are we missing? The y. Let's see. Let's go back up. Do we have anything that has y equal to something? Yeah, look at that equation. Don't we have this one? Yeah, so let's write it over here on the side. The equation was y equals 2x minus 3z plus 20. But instead of z, I'm going to substitute 3. And instead of x, I'm going to substitute negative 4. Bring everything else down. Let's simplify. Y equals negative 8 minus 9 plus 20. What is negative 8 minus 9? Negative 17 plus 20. Therefore, y equals 3. You're like, what? Let's go. Now, question before we finish, because we're still not done. Think about it. What is the solution to any system? Tell your neighbor, what is the solution to any system? The point of intersection. That means we need a coordinate. All right. So we open up big parentheses this time because now we have how many different numbers? 3. We start with x, so therefore it's negative 4. What is y? 3. And what is z? 3. X, y, z. And you're saying, why 3? Oh, because now I, in the third dimension, does everybody see what I'm talking about? So check this out. So let's graph this. X, there it is. Z, I pushed it back and now it's laying down. I go diagonally like that. This is X, this is Y, and Z straight up and down. There it is. This is Z. All right, so let's start with X, negative 4. Here's the point of origin. This is X, negative 4 is over here. So 1, 2, 3, 4. Negative 4. I put it like that sideways because it's laying down. Do you guys see it laying down? Yeah. What is Y? 3. 1, 2, 3. There's 3. It's also laying down. So if I was to plot just that point with using these two coordinates, it would be somewhere about right there. I just put that right there so you can see where it's at so far. But what do we need now? To either go up or down in the third dimension in Z of 3. So I go 1, 2, 3. That means this point, it goes upward. And I plot it right there. You're saying, what? Yeah, I'm trying to match this height right here. Okay, here goes it. Look up, please. It's laying down, yes? Here's X. X, negative 4 is over here. Y, 3 is over here. So that point, the original point's down here. But if I'm going off that, I go 3 steps up, so I'm somewhere right here. Okay? We good? Yay! Yeah, the third dimension is hard to visualize because it's hard to visualize. Okay? Here it goes again. This is X, this is Y, and this is a Z. Here it goes again. If you don't see it, let me show you again. This is x. This is the original y. Imagine I take the y, this is y, and I push it back so the plane is laying down sideways here, like on the table. Here it is. Okay? All right, good. All right, so let me zoom out. Look at that, huge merch right there. Solution. Solution. All right, show me with fingers how come you are with substitution methods without the graphing. Yeah, the graphing, we're not going to do the graphing. We're just doing substitution and elimination. Okay. All right, so let's see if you can do one by yourself. Bam, let's go. Copy this one, example 3Q. X plus 2y plus z equals 8. 2x plus y minus z equals 4. And x plus y plus 3z equals 7. Now, so that we all have the same process, look up. I want you to take this one, and for that one, I want you to solve for y. And then substitute into the other two, and then continue with the process. So which one are we using? The third one, yes? All right, let's see how you do. I'll give you guys some time. How about 1 minute? Okay, no, 5 minutes, 5 minutes. Ready? Go. Copy that and go. All right, let's check progress. Does it look something like that? Thank you. So far, you should have solved for y on the third one. There it is. Substitute that into the other two. There it is, and simplify. Hands if you got up to right there by yourself. Okay, good. Check your work. I'll give you guys a little bit more time. Copy that and go if you don't have it. All right, let's see the next part. There it is. We went from here. We made it into a system. Eliminate x's. This became negative 9z equal to negative 9. Divide by negative 9. Z equals 1. Hands if you got that. Good. Substitute that into one of the two. I just chose the green one. Solve. X equals 1. Hands if you got that. Okay. Give you 1 more minute to act like tomatoes. All right. So we went from here, from the last two, we have x and y. What do we do after that? We substitute into one of the equation, or the equation we already have solved for y. Yeah, the one you already have solved. So we take this equation up here that we had already solved, substitute the values, solve for y. And what is y? 3. So my solution, 1 of x, 3 of y, 1 of z. Hands if you got that. The z always goes at the end, in alphabetical order. X, y, and z. Yeah. Right here? Plus, minus. Oh, I just put plus minus 4. Yeah. It should have been negative 4, but you're fine. Yeah. All right. How are we doing? Show me your fingers how come you are with that. Okay. So we're done with substitution. Guess what's next? Elimination. That is correct. First, let's see this from afar. There, let's go. Look at that. eBay. Bam. No? You wouldn't pay for a culture like that? Ken's like, no. All right, here we go. Elimination. Don't copy this. Writing utensils down. Just look up, please. Here it goes. Ready? Pay attention, please. To use elimination, let's think about what the process was with just two variables. What did we do? They needed to be aligned in the same format, either y equals 2 or in standard form. Are they all aligned? Yes. Step 2, you needed to choose the variables that canceled or that eliminated in order to eliminate. Look at the two equations. Look for two equations where the variables are going to eliminate. Which equations? The second two, this one and this one. So watch. I'm going to focus on those two. What is 3x minus 3x? What is 2y minus 2y? What is z plus 3z? 21 minus 9, divide by 4, z equals 3. Did we get that on the first example that we did? Yes. Now, next step, I'm going to take the first two. What did I do first? The second two. Now I'm going to take the first two. I'm going to rewrite these. Negative 2x plus y plus 3z equals 20. And negative 3x plus 2y plus z equals 21. You're saying, Mr. Q, none of those variables cancel or eliminate. However, couldn't we eliminate either z or y if I multiplied one of the equations times something? So watch. I'm going to multiply the first equation because I want to eliminate y. What does this need to be? So I'm going to multiply everything times negative 2. That gives me 4x minus 2y minus 6z equals 2, negative 40. Now, I'm going to focus on these two and see what I get. Let's see. Negative 3x plus 4x, that's x. This cancels. Negative 6z plus z, negative 5z equals 2, negative 19. But wait a minute. Now I have a z value. What is z? 3. X minus 5 times 3 equals negative 19. X minus 15 equals negative 19. Plus 15 plus 15. X equals negative 4. Did I get that on the first example that we did? Yes. So what do we do with the x and y now? Yes. My question to you, if I wanted to eliminate these two y's, what does this one need to be? So I multiply times negative 2. All right. So I need to substitute these two into one of the three equations. Which one do you want me to use, the first, second, or the third? The first, second, or the third? All right, I'm going to use the first. So I'm going to do negative 2x plus y plus 3z equals 20. But instead of z, I'm going to substitute 3. Instead of x, I'm going to substitute negative 4. Negative 2 times negative 4 plus y plus 3 times 3 equals 20. 8 plus y plus 9 equals 20. Let me move up. This is y plus 17 equals 20 minus 17. Y equals 3. Am I done? No. Solution. Negative 4, 3, 3. Copy that. Woo! Let's go. Leo's all. We got the same thing as the first example. Yes, it's the same system. Copy that. All right, just one cautionary note. Look up, please. Let's say you started with the first two. Look up. And you ended up with this equation right here. We can't simplify anymore, right? Oh, sorry. This one. And you can't simplify anymore. And then you took the second two and you ended up with another equation that was negative x something z. What do you do with those two equations? Set them in a system and then solve that system like we did the other. Does that make sense? Yeah? All right. Show me your famous how confused you are with elimination. All right. Good one, guys. Home play is on page what? 217, 218. Good one. 216, 217. Sorry. 216, 217. Enjoy your home play. Make it a math movie night. Yeah, if you go to the YouTube channel. Let's go. tutoring for free. Bye.